together and welcome Senthilkumar to the stage.
I am Senthilkumar Subramanian, and I'm here to share my research on space and lunar exploration. Let's begin this. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. This is a famous moon speech given by President John F. Kennedy in the early 60s, before the actual lunar landings. It's been 50 years. Now we humans are planning to go back to the moon again in this decade. Do you all think this statement is still relevant, especially in today's political climate? Personally, I don't think so. So allow me to rephrase it. We choose to go to the moon in this decade and do the other things, not because they are easy, but because moon has a lot of resources and we need to grab it before somebody else does. Yes, that's the truth. So we are going back to the moon, all right? So our human intelligence advanced since the last lunar landing. With all these advancements, we will be reaching the outer planets in style. This time it's going to be different. It's not like old technologies. So it's not only NASA, but there are plenty of other countries are planning to send humans on the moon, including private players, Elon Musk. And also we'll be staying longer. We'll be there, in months, in years, and we are planning to build the habitats, and we'll be growing plants, foods, pizzas, right? And if all goes well, we'll make space babies. The funny thing about space babies is they'll learn to hope before they learn to crawl. So there will be separate space economy, space law, space culture, space ethics, and so on. And soon you'll be taking selfies on the surface of the moon with the blue earth in the background. It's all exciting, right? But what if I say all these good things can be shattered with a speck of a dust? This is Jensen, and he's an American astronaut, commander of Apollo 17. He's the last man to walk on the moon. If I'm a bit optimistic, he's the most recent man to walk on the moon. When asked about the experience on working on the moon, he says this: I think lunar dust is probably one of the greatest inhibitors to nominal operation on the moon. We can overcome other physical or mechanical problems except dust. Houston, we need a Hoover to clean the moon. So when it's seen from far, it's beautiful, elegant, and romantic. But when you're getting closer, it is such an irritation. Ladies and gentlemen, I'm talking about Earth partner, moon. If it resembles any of one of your partner, it's a pure coincidence. So to understand why Earth partner is such an irritation, so we need to understand how they are grown up. For example, Earth, we have water and the air. There is an erosion happening on the Earth, so it makes the soil more rounded and soft. But in the case of moon, there is no water, there is no air, and it's been constantly under the sun radiation. It's baked under sun radiation. So the lunar soil is basically dry and sharp, like glass particles. The other major difference is between the moon and the Earth is how the particles are being displaced. For example, on the Earth, the flying objects has been subjected by two kinds of forces. One is the gravity, which is trying to pull the object towards the ground. Another one is wind. The wind blows. There's the air molecule, so it's trying to stop the object to go further. So obviously, the ball, is smashed on the ground within a small distance. But with the same force, if you kick the ball on the surface of the moon, it go higher and further. The reason being, moon has 6 times lower gravity than the Earth, and there is no wind on the moon to stop the ball, right? So it can go further. Now imagine a future situation. We have a lunar settlement, and we will be landing our rocket near to the settlement. And obviously, the future rockets going to be big because we are going to carry a lot of astronauts, tons of cargoes. So it will produce a huge amount of thrust, and this thrust will stirs up the lunar dust and this lunar dust is going to liberate in all the 360 directions. And combined with the low lunar gravity and no atmosphere on the moon, these particles behave like an army of tiny bullets because they're flying at a very high speed and can potentially damage anything in its path. In fact, some scientists claim these particles can indeed go into the space, get into the orbit, and it can damage even the orbiting satellites on the moon. Imagine a situation if this is an American rocket and this is a Russian satellite, and this is happening on the moon, or the other way around, for example. We just started a space war, right? So, the dirty politics on Earth has been upgraded to dusty politics on space. We have enough war on Earth. We don't want to create another war on space. So, we need to understand the dust behavior on the moon. This understanding will help to develop a better rocket engines, develop a better landing pads, launching pads on the moon, and also to help build better habitats. So for this purpose, we at Aerospace Physics Laboratory in University of Glasgow, under the guidance of Professor Kostas and also with the financial support from European Space Agency, we designed and built a huge vacuum facility, which is called Plume Regolith Facility. You can see the size, it's really huge. It's located a few kilometers away from this place. It's a part of University of Glasgow. So basically, the idea of this facility is to understand how the dust behave, the extraterrestrial dust behave during the rocket landing or launching. So we have the chamber here. The chamber is basically a metal container with a lot of windows to look through, and it has a single door, and it's connected to a hoover, and sorry. That's the simplest way to explain this. We have vacuum pumps, 2 vacuum pumps, huge vacuum pumps, because we need to bring all the air inside the huge chamber and make it in vacuum conditions to replicate the actual lunar scenario. So we suck out all the air molecules and create a vacuum conditions that have the lunar, as I said, and we install a small rocket, a scaled down lunar rocket. Based on a lot of similitude analysis. That's the half of the story. But the main ingredients is missing here, which is the lunar dust. Unfortunately, we don't have lunar dust on Earth, all right? There's a funny story. NASA does have some lunar dust. They collected from moon, but they kept it in a vacuum flask. Since the lunar dust are sharp, it's a crack. The seal got cracked, and the atmosphere pressure leaked inside and all got contaminated. So we don't have lunar dust technically. Anyways, but we have simulant. A simulant is a terrestrial material synthesized in order to approximate the properties of the lunar regolith. Here the regolith means it's a dust, basically a scientific name. So we have lunar regolith. So for my experiment, I choose hollow glass microspheres as a simulant because the shadow region on the moon, which is called the mare region, do contain some kind of considerable amount of glass particles, so we can match this. So now I took a tray and filled the tray with this glass microspheres, and that simulate the lunar surface and fire the nozzle, fire the rocket, right? So after firing the rocket, we have the ejection on all the 360 direction. But the idea of this experiment to track the particles, the flying particles, to track, we have a high-speed laser, which is synchronized with the high-speed camera. In fact, the high-speed camera captures like 3,000 images per second of this ejection event. And after processing all these images, and finally we can able to get at what velocities these particles are ejecting and what angle of inclination they are ejecting. So basically, in other words, we understood how the dust behaves during a lunar landing. We also I tried the experiment for the Martian condition. In case of Martian condition, we need a different kind of rocket because Mars does have a thin atmosphere, around 600 pascals. So we have a different rocket designed for this purpose, and also we need to choose Martian simulant. Well, for the Martian case, we don't have any return trip from Mars so far, so we don't know how it exactly looks like, but we do have some robotic missions. So we have some idea. We chose for this experiment a strange simulant. It's a color, it's a Martian color, and it is organic, and it is consumable. You can eat it. I know what you're thinking about me. Yeah. We PhDs are nuts. Well, the devil is in the details because the simulant is actually walnuts. So we crushed the walnut shells into microns size, and that we used to replicate the Martian soil, and we did the experiment for the Martian case. And finally, this is me after all my hard work, wearing all these suits, because dealing with the lunar dust is really difficult, guys. Like these glass particles, it's very small size, and it's everywhere, eyes, ears, everywhere. And finally, we get some good results, and we publish in a top journal, and it's been accepted. I mean, it's published as one of the best in the journal, and also it's published in magazines. And we are very proud of it because it's one of the kind of experiment we are at the forefront in Glasgow University. Finally, if you get a chance in the near future to land on the moon, if you are scratching your head for a perfect one-liner to say when you step on the moon, try this. One small dusty experiment on Earth, a giant leap in space exploration. Thank you.